The truth is, if we don't do this, we're about to lose our ability to fight alongside allies because they are driving forward with maximal speed on their own digital transformations.
Hi, I'm Captain Orton with the Canadian Army Podcast. Command and control is essential in the battle space while training, on operation, when working with our allies, pretty much any time. Dealing with large numbers of soldiers in the field is really complicated, and we need to make it easier. Two of the people leading the charge on reshaping the Army's relationship with technology are Lieutenant Colonel Dan McKinney and Lieutenant Colonel Tom McMullen. They are both here with me to unpack what possible advances can take place for the future of command and control with the Canadian Army. Welcome to the podcast.
Thank you.
Yeah, thanks for having us, Adam.
So let's start with, what is command and control? Lieutenant Colonel McKinney, what is that function and why is it important?
So command and control is essential to all other aspects of how the military operates. In the Army context, command and control is how our commanders can arrive at decisions and then take those decisions and order for actions to be done on the ground. So this could be a maneuver of troops. It could be some fires. It could be collecting intelligence, all matters of things. So what we say is whoever wins in the decision space will win in the battle space. And having a robust command and control capability is what enables you to win in the decision space. Tom?
Yeah, and it's ultimately the fabric that binds everything else that the Army does, all its other functions. So if you don't have a good command and control system, you're not able to sense what's going on the battlefield and make sense of it. And you're not able to get the information and to pass down effective decisions. So ultimately, it's about decision advantage and making sure commanders are best supported with the decisions that they're making.
Well, this is a military term, but it's applicable across the board, is the OODA loop, right? Observe, orient, decide, and act. And the faster that you can go through that cycle, the easier it is to get ahead of somebody else who you're competing with in the same kind of space.
Exactly. So we often use the expression in the military to try to get inside the enemy's OODA loop. So it's recognized that the Army with the most effective OODA loop is the one that's going to win, because you're always going to be taking action while the enemy is always focused on trying to figure out what's going on to decide upon their own actions. So it means that you maintain the initiative in a fight.
So what are some of the limitations of how we do business now, Lieutenant Colonel McKinney?
We're doing things, pardon the expression, hydraulically, as opposed to using a modern command and control system, which is fully integrated at the digital level, so at the ones and zeros. So I'll give you an example. We have teams that are responsible for uncrewed aircraft systems. Those systems are flying around, they're collecting imagery, they're collecting data. We have other crews that are responsible for radar systems. Those are also collecting information on enemy dispositions and threats. They are not fully integrated in our system. So right now, you actually have operators that are using radio traffic to get that information up to higher headquarters. And at higher headquarters, then you have another group of people that are taking that, they're converting it to a chat signal, and they're explaining, to their higher headquarters what they saw, and they're putting everything together. And then at some point, there's the decision on, okay, are we going to use the effectors that we have? So, for example, artillery or close air support to target those threats that were identified. But that entire, what we call the kill chain, is very lengthy because the systems aren't integrated at the data level. So that's what we're trying to improve with these systems, is that by integrating everything, what we've discovered with our allies is they can take a kill chain from something like 10 minutes to under a minute, basically, to affect a target. So that is a huge advantage in the battlefield.
Lieutenant Colonel McMullen, what are some of the inherent problems with those extra steps in between point A and point B, time notwithstanding?
Yeah, so you mentioned time is always going to be the biggest one in terms of getting the speed of decision and getting inside, like you mentioned, the enemy's OODA loop. Other major problems are just our ability to actually show up and be able to plug in with the coalition and our allied partners on operations, on training. So we're showing up with systems that are generally very resource intensive to engineer and to sustain. And we're showing up to these training events and we're not able to plug them in to the coalition networks and coalition systems without a lot of time and effort in engineering and integration. So that's a huge hurdle right now is we just can't show up to these things and plug in.
Lieutenant Colonel McKinney, I really appreciate also your comment on the chat because I remember in Afghanistan, they had what they called the Merc, right? Which
That's right.
is it's kind of a throwback to the 90s internet relay chat, right? And I saw that, I was like, what? I used to chat with my friends on this in the 90s, and it's something that we use in the battle space today to send timely communications. And it's a good system in terms of robustness, but also to some people might seem dated.
Well, if you think about it, though, when they introduced chat, there was a lot of debate about it. I was a young captain in Afghanistan, and I saw this system. It seemed on the surface to be slowing things down because we were used to only voice traffic before we actually had the chat. But what it did in terms of the slowdown when it came to typing something out, you actually gained that time back later because everybody could see it at the same time. And then errors were easy to identify because, you got to think before the chat, we're using logbooks and carbon paper. So that was what we call digitization of a system. What we need to get to now is digital optimization and then digital transformation, which are the next steps.
And that's a really good segue is before we were at somebody furiously scribbling on a field message pad or something like that. Now, at least it's held in the digital space. So Lieutenant Colonel McMullen, what's the next step from a functional standpoint? What are we looking at next? What's the next cool thing?
So, Adam, ultimately, there's still a digital divide that exists within the Army. We mentioned these digital systems and digitalization, but really it's only at the battle group and higher levels, brigade levels and higher. At the company level and below, there's still a digital divide where we're still very much analog in our processes. We're still very much on field message pads, map and compass. It's getting better, but it's still largely voice driven. And we're not able to get digital data down to that level and back up to feed decision making. So there's still that digital divide. So that's where these upcoming modernization projects, and there's 6 major ones that are coming in the next few years. So we're talking major investment into modernization of the Army's current command and control capabilities. And we're really speaking about the size and scale of this, of scaling it down all the way to those company levels and below soldier levels to eliminate that digital divide.
I find it interesting you bring up the map and compass thing because we talk about that a lot. It's like, why can't I use my GPS and all that? But then there's also the functional aspect of the simplicity of a map and compass versus, something that doesn't work or you can't remember which buttons to press, which may seem simple, but sometimes like these systems are pretty complex. Lieutenant Colonel McKinney, what do you think about the potential challenges of introducing that complexity at the soldier level?
I actually don't see it as so much of a challenge. Like everybody has a smartphone today. You call Uber, you order, skip the dishes, and it's 3 clicks away. You can get fed, get a ride, etc. And I think it needs to come to the same thing in the military context, where an injured soldier or a section that has a injured member, they can press a few buttons on their smart device and know that air medevac is on the way, as opposed to using that map and compass, figure out exactly what grid they're at, and then that's all time that you end up wasting for the casualty. But that could be true for all arms call for fire. Could be true for just relaying quick orders, giving a quick situation report on what's happening on the battlefield. So back to your question in terms of the challenge of bringing in these tools. So I think we're challenged now by the fact that we don't have the tools more than the actual challenge of bringing in those tools, because I think we're just not meeting expectations right now.
Lieutenant Colonel McMullen, anything to add on that?
Yeah, Dan mentions like these new tools that are coming in. The forcing function is really getting on board with, how modern warfare is fought and making sure that we're keeping up with our allies, certainly. And if our soldiers are going out to Latvia on things like op reassurance and don't have the digital tools that our allies do over there, it keeps Canada a step behind, the Canadian Army a step behind. Not to say that the old ways of doing things aren't good. There's still always going to be a need to train those analog processes and those kinds of systems, as well as I do. When things heat up in an actual fight in a contested environment where your comms could be jammed or you could be denied, you need to rely on some of those backup ways of doing things. But we can't use those as our primary systems. It's certainly the case these days.
Just to emphasize what Tom just said, so I fully agree that we need to keep training the old way of doing things. Okay, the analog way is the only way that can't be jammed. So we know that some of our potential adversaries, they see Western nations investing a lot in digital, and they can't necessarily keep up with that level of investment. So for them, the ability to level the playing field is important. So they're going after directly where we harness our advantages from. So digital, for example. So you can see there's some reports coming out of different conflicts show that using jammers very heavily. So we need to be able to operate in a degraded environment.
So with all this said, what are some of the new tools that we're getting access to, Lieutenant Colonel McMullen?
So it's across a range of modalities. So the highest level is at the headquarters level. So we're talking tools in terms of software and servers and data storage. At the lower level, the tactical level, we're talking new radios, new communication systems, new satellites. So in terms of the infrastructure, it's building those communication transport layers and then making sure that we have the data architecture riding on top of that so that information can flow between soldiers, between commanders. We can make the best informed decisions we can, and we can plug those systems into our coalition allies as well.
Do you have anything else to add, Lieutenant Colonel McKinney?
Like Tom said, it's a bit of everything, but it's the integration aspect where you get the value from, right? Because you can have, like, for example, one of the projects is electronic warfare modernization. But if you're only doing electronic warfare where you're sensing the electromagnetic signatures that an enemy could be emitting, but those tracks aren't getting anywhere and they're not being verified by another sensor to make sure that what you just discovered is actually an enemy position, and then that's not being fed to your software that's enabling decision making, then you can't arrive at a decision where a commander could be comfortable ordering a strike on that position. So the value we're getting is from the integration work so that we have all these systems that are actually working together so you can get to a decision, but then you can quickly do something about that threat.
When you talk about decision-making software, are we looking at the implementation of artificial intelligence to assist command with making decisions?
Yeah, so that is something we are looking at, and that will be key. Machine learning and artificial intelligence are going to be key to any future command support system. But right now, it's very much in an experimentation mode. So we have scientists that are working on it. We have lessons learned from our allies that are able to use basically a piece of software, which is a kind of smart piece of software, to recognize patterns on the battlefield, to be aware of the different sensors we have out there so that if there's something that's detected, the system can cue another sensor to have a second look until a point where there's a certain level of confidence of what that potential threat is. So it basically feeds to the human being something that is better packaged in terms of its decision quality, let's say. What's important, though, and I know people will sometimes get scared when we talk about artificial intelligence because, we've watched a lot of movies and Terminator and all that stuff. But one thing that it's important to emphasize is these systems, at the end of the day, there's always a human in the loop. So what it's doing is it's building the picture in a way that would take a lot more human and time to do, but it's building it so that the human can make a better decision. At the end of the day, it's all about saving time and then increasing the accuracy of the decisions because you've actually checked multiple different pathways to make sure that what you're looking at is actually what you think you're looking at. So you're taking a lot of potential for human error, because there's no such thing as a late Friday or an early Monday for an algorithm, right?
Right.
It operates the same way at every turn. And then there's always humans that are verifying at every step. That's just important to emphasize.
Yeah, when you described that, I pictured a chessboard with people playing chess, and that as a human, you're analyzing all these options. But like you said, if you're off your game or whatever, you might miss an obvious move. And like the AI would do the analysis and say, here are the top 3 probable outcomes here. And it just gives you an extra piece of information for decision making. The computer's not playing the game for you. It's just telling you these are the probable outcomes and highlighting those to give you ready access to potential moves in terms of analysis instead of your brain having to do all the work.
Exactly. Maybe if I can give you an example, right?
Yeah.
So just imagine if, we have a bunch of sensors everywhere on the battlefield. And from those sensors, we captured a whole bunch, like terabytes and terabytes and terabytes of data, of imagery. And let's say an incident happens where a car, let's say it's a vehicle-borne improvised explosive device, and it crashes into a gate or something. Then you're trying to figure out, okay, where did that car come from? Do we have previous imagery of that car? So imagine the amount of humans that you would have to employ to watch all the feeds and the terabytes of videos to figure out, where did that car come from? So this is something that computers do very easily, right? You can have your computer at home figure out, match your face and put all your family pictures together on its own. So I'm sure a lot of people listening to this have, Google Photos that does this on their own. It organizes everything by specific person or location, etc. So artificial intelligence and machine learning is actually able to do that today. In the Canadian context, we're not doing it, but that's just one example of how much time you would save to gather that one critical piece of intelligence to figure out where that attack came from.
Can you explain a little bit, because I know in a lot of people's minds, you say sensors and you're thinking some sci-fi magic detector, but in the military context, that actually means something different. Can you kind of explain what that actually is?
We have a lot of different sensors. When we say sensors, it's anything that you're thinking about your eyes and ears kind of thing. So we have cameras, we have electro-optics, we have electronic warfare sensors that are picking up the electromagnetic activities. So if enemy location is broadcasting, then it picks it up. We have electronic intelligence, which is picking up the electronic signatures of different pieces of machinery because they also emit. So just to simplify it, I guess, into different categories, I would say, when we talk about sensors, we're talking about UAVs or unmanned aerial vehicles. We're talking about ground-based sensors that are integrated into different vehicle systems. So, for example, a recce squadron would have some sensors. We're talking about radars that they would detect movements. So those systems emit something and get something back. So what we say is that the battlefield is becoming increasingly sensor saturated, and sensors are becoming more and more sophisticated and more precise on what they can pick up. But what that means is that they're generating a lot more data, and too much data for humans to parse through and arrive at a conclusion that enables you to take action from that data. So we actually need the computer systems to go through all that data in order to paint a picture that is of decision quality for a commander.
Yeah, and as they say, every soldier is a sensor too. There's a human on the ground taking pictures, sending things up through radio and all that as well.
Absolutely.
It's a lot of moving parts.
Absolutely.
Lieutenant Colonel McMullen. So we've been talking about all this stuff here. What's it all called? How are we going to describe this?
So yeah, Adam, the way we're characterizing this whole effort is what we're calling integrated command and control system. It's 6 main projects, which are the backbone of this modernization effort. They're all independent projects and they all kind of serve their own individual purposes. For everything from the communication systems themselves to the command and control systems to the sensor modernization. It's how do we integrate these projects together? And that integration is the key word in all of this, and taking a systems approach to this. Because if we deliver 6 individual projects, independent projects to this, we're just going to make the current problem we have worse in terms of stovepipe systems, fragmented systems. So these projects on their own will deliver capability, but the real juice or the fruit of those capabilities is how they're going to be able to integrate together to form a collective whole.
Where are we in the implementation process of this at this stage in the game? Is this going to happen?
So yeah, Adam, the projects right now, they're still in what they call options analysis phase. So that's one of the project approval process phases. So right now, the effort is to get these projects into definition where we can actually start spending some of the money and to get it approved by minister and higher levels to start spending this money to be able to get, whether it's prototypes or new iterations. So we're expecting to get that within the next couple of years. Currently, we're setting those high-level strategic options in terms of the major projects. So it will happen. It's not about getting the perfect solution out there. It's about getting something out there and then being able to iterate and to improve that capability once it's fielded out there. So similar to a smartphone, like, just because you have a smartphone doesn't mean that you have the best applications that you can load onto it. But over the life cycle of that smartphone, new things come out, new software updates, new apps come out that you're able to constantly be kind of improving on that. So that's the idea here, is getting that infrastructure and the big money investment into those pipelines out into the Army, and then being able to get into a cycle of innovation for the software that we're fielding.
Procurement's always a challenge, but this seems like it's quite a large project. What are we talking about here? How big is this?
So, Adam, it's big, it's important, and it's going to ultimately serve as the underpinning or the backbone of the Canadian Army modernization strategy and how we're going to be able to fight as an effective force into the future. So the Army is treating this family of projects similar to how the Air Force is treating next-gen fighter, similar how the Navy is treating their new surface combatants. So for the Army, these projects represent that leap we need to make into the digital world of being able to modernize the functions of how the Army operates.
So you're talking about the next-gen fighter and, for the Navy, it's ships. What's the challenge of defining this as a scope for project delivery in the sense that we need X amount of fighters? Easy explanation. We need X amount of ships to cover X amount of space. Easy explanation. We need better command and control systems. How do we explain that?
The truth is, the Canadian Army right now, we pride ourselves in being able to plug in to our allies, to be that flanking formation, to be that force package that, we can seamlessly, the Government of Canada can offer up to a coalition fight, and we're able to fight, and we're good at it. If we don't do this, we're about to lose our ability to fight alongside allies because they are driving forward with maximal speed on their own digital transformations. So if we're no longer able to exchange data, if we're no longer able to make decisions at the same speed that they're making them, if we're not able to target enemies that are in our front at the same speed as they're targeting theirs on our flank, then we're not an effective partner. So that's one of the big drivers for sure, is basically innovating at the pace we need to in order to remain relevant as a fighting force.
Last word to you, Lieutenant Colonel McMullen.
Yeah, just to say, for the individual soldier, at the end of the day, at the unit level, it's about simplifying the current systems that they have and removing some of the complexity they have in terms of their tactical radios and their command and control systems that we currently have that are very hard to sustain and train. So it's revitalizing that and making sure that we're giving them the tools that they need to do their jobs and also empowering them in terms of solving their local challenges and their local problems. So it's not a big top-down driven thing. It needs to be bottom-up so that we're actively listening to their requirements, and we're going to continue to do that. So I would encourage, soldiers listening that the current problems and the current challenges that they have with their command and control systems when they deploy into the field, to make sure that they're signaling those up. And we've had some good engagement so far with a lot of the brigades and the units out there, but we're going to continue to do that to make sure that we're translating their functional and their user requirements into the documents that we're writing for these projects as well.
Well, thanks very much for taking the time to talk to us today.
Thank you.
Thanks, Adam.
That was Lieutenant Colonel Dan McKinney and Lieutenant Colonel Tom McMullen talking to us about the future of command and control with the Canadian Army. If you want to know more about digital transformation in the Canadian Army, take a look at Season 2, Episode 13, The Digital Army, available where all good podcasts are served. I'm Captain Adam Orton with the Canadian Army Podcast. Orton out.